is a section that is all about sketching curves. Curve sketching means taking a look at a graph and determining what the curve of the graph would look like for f prime of x or f double prime of x if you're given f of x, or if you're given f prime of x, what would f of x or f double prime of x look like? As long as you understand the relationships between a function and its derivative, this isn't so bad. There's a little bit of memorizing perhaps, but it's really all about the relationships between a graph and its derivative. Okay, so let's start here with the graph of f of x. You're not going to be writing much for a bit. Okay, the graph of f of x. How can you tell when it is increasing or decreasing? So if your graph literally is f of x, it is increasing or decreasing where the graph is moving up or moving down as you go from left to right. Graph of f of x has a relative max or min at the top of a hill or the bottom of a valley. So these things are maybe the more obvious things on a graph when you're looking. These are things that you learned back in like Algebra 1. What does a graph literally look like? So if this is like your x and y axis, then if this is like -1, that's -2, that's -3, and this is, let's just go with +1. We know that our graph is increasing from -infinity to -2. It is decreasing from -2 to 1, and it is increasing from 1 to infinity. Relative maxes and mins happen at tops of hills, bottoms of valleys, and that's also where your graph switches increasing and decreasing. So your graph switches from increasing to decreasing at maxes, switches from decreasing to increasing at mins. Critical points are the x values. Usually we look for the critical numbers, which are the x values, where your maxes and mins are, or where you have weird things like sharp turns and vertical tangents. Okay, so anytime that your derivative would equal, well, that would be talking about your derivative, right? But the slope of the tangent line would be 0 or undefined, something weird going on at that point. So you can have sharp turns like corners and cusps, or you could have vertical tangents, something like this. A vertical tangent would occur here, like the graph of y equals the cube root of x. The next thing is concave up and concave down. Concave up means your graph is cupped up. The cup is facing up. It could hold water. Concave down means that your cup would be facing down. So from here until about maybe here, our graph is concave down, and then it switches from concave down to concave up. Okay, if you could hold a cup in front of you and it looks like it is upside down, that is concave down. All right. Points of inflection happen where the concavity changes. And generally, again, we just care about the x values. Maxes and mins, we care about the y values, but for the most part, everything else we just care about the x's. So points of inflection are where concavity changes. This graph changes concavity at about x equals -1. It doesn't matter that that was on the x-axis. That was more of an accident than anything else. Okay, so we switch from concave down to concave up at x equals -1. So that is a point of inflection on this graph. That is the only time on this graph that we change from concave down to concave up or the other way. So that is the only point of inflection that happens. Okay. Let's say that instead of given the graph of f of x, you're given a graph of f prime of x. What that means is that the y values on this graph are the slopes of the points, the slopes of the tangent lines of points that would have been on your f graph. So the y values on the slope, the y values on the graph of f prime are the slopes from the f graph. which is not shown. Okay, so if you're given the f prime graph instead, your y values are the slopes. X values are x values no matter what. Just the y values, what they mean, changes. So we know from the graph of f of x that your function is increasing when your graph is going up. Well, here the graph is going up, and on every single spot there, the tangent line would have a positive slope. So that means that your graph of f prime would itself be positive. The y values on the f prime graph would be positive from here to here. And then, since our graph of f of x would be decreasing from -2 to 1, the graph of f prime of x would be negative in that interval. Then from 1 until infinity, f is increasing, which means all those little tangent lines have positive slopes. Positive slopes go for increasing, so positive, your graph of f prime of x would have positive y values, meaning you're either above or below the x-axis. I'm going to add that on here, above or below the x-axis. Next, relative maxes and mins happen at critical numbers. Critical numbers happen at the top of a hill or the bottom of a valley, right? At relative maxes and mins, top of a hill, bottom of a valley. Well, at the top of a hill, we know that our graph switches from increasing to decreasing. At the bottom of a hill, our graph of f switches from decreasing to increasing. So our slopes are changing signs, either from positive to negative or negative to positive. That means that the graph of f prime of x would have to switch from positive to negative, and that happens at zeros on graphs. So this is where your graph crosses the x-axis. Crosses the x-axis. Right? That means it switches signs, positive to negative or negative to positive. If your graph of f prime just touches the x-axis and does not switch signs, right? It doesn't go through, it just touches. That means that your graph of f of x would have been increasing, then there would have been a horizontal tangent, and then it would have kept going back up as increasing still. Okay. Next guy, critical points happen at relative maxes and mins, sharp turns, and vertical tangents on f of x. So that happens where f prime equals 0 and where f prime does not exist. So we're looking for where f prime crosses the x-axis because the y values equal 0, right? Because f prime of x equals 0, or f prime of x does not exist. It's undefined. Okay, so there'd be like no point there. Next thing is concave up and down. Okay, so where is our graph cupped up or cupped down? When we talked in a previous section about the second derivative and the second derivative test, we talked about how if the second derivative is positive, your graph is cupped up, so that's going to be like this, and that happens where f prime of x is increasing. F prime of x would be decreasing here. So your graph of f of x would be concave up or down when the graph of f prime of x is increasing or decreasing. Right? Slopes increasing or slopes decreasing make f of x concave up or concave down. So all of these words, again, refer back to how f of x behaves, not how f prime behaves. So this is for f of x, and all this stuff is what f prime of x is showing on its graph. The last thing in this list is point of inflection. We talked about how points of inflection happen on the f of x graph where we switch from concave down to concave up. Okay. So points of inflection would happen when concave up and concave down switch. So where does the graph of f prime of x switch from increasing to decreasing or decreasing to increasing? Well, increasing to decreasing changes at maxes, and decreasing to increasing changes at minimums. So we're looking for a relative max or a relative min of f prime of x. So looking at the graph of f prime that you're given, where are the maxes and mins? That's where f prime switches from increasing and decreasing between those two, which means that f of x would have a point of inflection. Okay, last little bit on here is the graph of f double prime. It is not as often that you'll be given a graph of f double prime and asked to tell things about f, okay? But everything that we know about f prime means the derivative of the previous function. So if you're given f double prime, it's the derivative of f prime. So you can figure out things about f prime if you're given f double prime, and vice versa. Okay, so these two have the same relationship. These two, f prime and f double prime, have the same relationship that these two do. The graph of f double prime of x. If you know that f double prime is positive or negative, you know that f of x is concave up or concave down. The last thing, point of inflection, where your graph crosses the x-axis. Because points of inflection happen where concavity changes. So if the graph is positive and switches to negative, that's going to happen when f double prime of x crosses the x-axis. Okay, switches from positive to negative or negative to positive. Okay, and that's really it. That's what we got. I'm going to take this all and put it in a table. I would recommend you try and put it in a table yourself. It's really just all the stuff from up above, organized maybe a little bit differently.